Hey Vamsi, this line introduces a quiz question focused on the check_cv function from the scikit-learn library in Python. It's a multiple-choice question designed to test your understanding of this function's role in validating cross-validation strategies. This statement claims that check_cv will signal an error, a value error, if you give it a cross-validation method that it doesn't recognize or that's incorrectly formatted. Think of it like this: if you try to use a recipe that's missing ingredients or has unclear instructions, your attempt to bake will fail. This statement checks if that recipe, your cross-validation method, is valid. This one suggests that check_cv directly changes the original cross-validation object you provide. Imagine you have a clay sculpture. This statement implies check_cv will directly reshape that existing clay. Let's investigate whether this is actually how it functions. This option proposes that check_cv only works with a specific type of input for the number of splits, n_splits. It's saying that you must provide a whole number, integer, for how many folds you want in your cross-validation. We'll see if this is a strict requirement or if there's more flexibility. This statement asserts that check_cv is versatile and supports different ways of splitting data for cross-validation, such as kfold stratified kfold and shuffle split . It's like saying a Swiss Army knife has various tools for different tasks. This assesses whether it's a general-purpose validator or only works for certain types of cross-validation methods. This is the core question of the quiz. You need to choose which of the previous statements, A, B, C, and D, accurately describe how the check_cv function operates. This simply labels the section containing the main question about the check_cv function. This indicates the section listing the possible answers, A, B, C, and D, to the multiple-choice question regarding check_cv . This line presents the core question of the quiz. It's asking you to identify which statements accurately describe the behavior of sklearnmodelselection, a function in the popular Python library scikit-learn used for validating cross-validation strategies in machine learning. Think about what you know about the function before reading the options. Option A states that if you give the function an invalid method for splitting the data, the function will signal this with a valuerror. Does that sound right to you based on what you know about error handling and data validation? This is option B. It claims the function changes the input data directly. Think about whether functions should modify their inputs directly, or if it's better to keep the original data unchanged. What are the pros and cons of each approach? Option C suggests that checkcv only works with a specific type of input, an integer value for the number of splits, nsplits. What other types of inputs might be valid for defining a cross-validation strategy? Think about things like kfold and stratified. Option D says checkcv can work with multiple types of splitting methods. Do you think this is true or false? Try to recall the types of cross-validation techniques you've encountered. This line introduces the subject of the quiz: understanding the sklearn model_selection. Check_cv function in the sklearn scikit-learn Python library. This function is super important for validating your cross-validation strategy before you use it to train your machine learning model. It ensures that the strategy is correctly configured and will work as expected. This line sets up a multiple-choice question, prompting the user to select the correct statements regarding the behavior and capabilities of check_cv . Let's see how well you understand this essential function. This is the first option. The statement claims that if you feed check_cv an incorrect or invalid cross-validation strategy, represented by the $cv object, it will raise a value error to signal the error. This is a common way functions handle unexpected inputs. Option B describes how check_cv handles the input. It asserts that the function directly alters, modifies, the input "cv" object, making it suitable for use. We'll need to determine whether this statement is accurate. Option C limits the "cv" object inputs. It states that "check_cv" exclusively takes integers for the "n_splits" parameter, which typically represents the number of folds in a cross-validation process. Is this true, or can it handle other kinds of inputs? Option D describes the flexibility of "check_cv". It suggests that the function can work with various types of cross-validation techniques, including "k-fold", "stratified k-fold", and "shuffle split", which are all different ways to split data for cross-validation. This describes what the "check_cv" function takes as input, a "cv" object. A "cv" object specifies the type of cross-validation splitting to use, such as "k-fold", "stratified k-fold", etc. This specifies how your data will be divided into training and testing sets for cross-validation. This simply labels the function under discussion. This line explains the possible outputs of "check_cv". Either it will return a validated version of the input "cv" object, confirming that it's a valid splitting strategy, or a "value error" if the input is invalid. This refers to the function sklearnmodelselection in the skitlearn library. This function is used to verify that the cross-validation strategy you provide to a machine learning model is valid and will work as expected. It's like a pre-flight check to avoid errors later. The quiz question asks you to identify which statements about sklearnmodelselection are true. It tests your understanding of how this function works. Statement A says that if you give checkcv an invalid cross-validation strategy, it will signal this with a valuerror. This is a way for checkcv to tell you something went wrong early in the process, rather than letting the problem show up later. Statement B suggests that checkcv changes the cross-validation object you give it directly. This is incorrect. Instead, checkcv creates a *new validated version without affecting the original. Statement C incorrectly states that checkcv only works with integers representing the number of splits, like in k-fold cross-validation. It's more flexible and can accept various types of cross-validation strategies. Statement D correctly indicates that checkcv supports a variety of cross-validation methods, including kfold, stratified and shufflesplit. This makes it very versatile for different data situations. The input to checkcv is a cross-validation object. This object defines how your data is split into training and testing sets during model validation. Examples include kfold, stratified kfold, maintains class proportions, and shufflesplit, random splits with replacement. This refers to the main focus of the problem, the checkcv function itself. The problem tests knowledge of this function's capabilities and limitations. The checkcv function either returns a validated cross-validation object, meaning it passed the checks, or raises a valuerror if something was wrong with the input. This is an important part of its error handling. This line introduces the core topic. Scikit-learn's "check_cv" function, which is used to validate cross-validation strategies. It sets the stage for understanding its purpose and how it works within the machine learning workflow. Think of it as a quality control step before applying cross-validation to your data. The core question of the quiz is presented here. It asks you to identify which statements about the "check_cv" function are correct. This focuses the discussion on the function's behavior and capabilities. This is one of the multiple choice options. It describes the function's error handling mechanism when encountering invalid inputs. The function will throw a value error if the cross-validation method provided is not suitable. This is another option, and it highlights a potential misconception about how check_cv works. It claims that check_cv modifies its input directly. We'll need to determine if this is true or not. This option presents a constraint about the input types the function accepts. This is important because the "cv" object can come in many forms. Do we need to check if this is a correct assumption about "check_cv"? The last option in the quiz. It tests whether the function can support different types of cross-validation methods. We'll need to verify if this is correct or not.